In this project, we're going to create a custom class to read in data from a text file, and the data we're going to use is a series of movies. And so let's look at the data file. This is just simply a text file, but I've delimited each of the fields with a vertical pipe. Now traditionally we use commas or we might use tabs, but I want to demonstrate you can use any character you want, and I think there's sometimes an advantage to setting up your data using a character that normally is not used in creating files. And one of those certainly is the vertical pipe. And you might do that if your data is going to contain commas and or tabs. You need to find another character to use as the delimiter. So here the format is I've got the title, and that's separated by a vertical pipe from the year, and then the director, the genre, being such as comedy or drama or thriller, the rating, PG, PG-13, R, and then the cast members are names of actors and actresses, and they are comma separated. And so each line of my data file, the first line is simply the header that explains what the fields are. And then starting with line 2, we have our data, one movie on each line, again separated by vertical pipes between the fields. We're going to read this data into a custom class called movie, and that custom class will contain attributes for each one of these fields, and then we'll create some accessor and some mutable methods to be able to change or to get those field values, or those attribute values, and then we'll also do some methods that manipulate this data a little bit. So that's going to be our custom class. We're going to save that as an external file, and then in our Python program we'll import that custom class and we'll work with the data and create a menu for the user. So let me show you the project running. I'm going to close my data file. By the way, the data file here is called movies3.txt, and that data file is available in the Canvas assignments area for this particular assignment. I think I also put it in the modules area for week 6. So here's my program running. It's going to import the data from the text file, and if all goes well, it should give us a print message saying movie data has been imported. Everything succeeded. If something goes wrong, maybe it can't find the file, there's some values in the file that are messed up, then we would get another error message here instead. But this worked, importing the data, and then we have a menu, and the user has some choices of what they can do. So one of those choices is they can type an A, and it can be lowercase or uppercase. We'll take the case sensitivity out using .upper string method. So I'm going to type in an A, and I get a listing of all the movies. Now there's about 31 movies here, I believe. They're in no particular order, so they're not listed alphabetically or by year. They're just kind of as I thought of these movies, I stuck these in. Once it lists those movies, I'm again asked to enter another choice. If I type a question mark, I can see that menu again. So the option here for the question mark is show the menu. If I type a 1, I'm going to take that data, and this data is stored in a list of instances of my class called movie. And each instance contains all the data for that particular movie. If I type a 1, I'm going to sort that list using a method that's built into the class, and I'm sorting it alphabetically by title from A to Z. So now if I list the movies again, they're in alphabetical order, starting with A Few Good Men, Apollo 13, so we got A, B, D, D, F, and it comes all the way down to the final movie is The Ultimate Gift. I'm going to do choice 2, which is to list them chronologically. Now here I'm using a sort method that is part of a list, and it tells me that I've sorted the data chronologically. Now I'm going to sort or list the data again. And now if we look at this, the bottom one is the most recent, 2015, 2011, 2010, 2010, so forth. If we go up to the very top, the oldest movie in this list is The Man Who Knew Too Much from 1934. By the way, you can see here there are 2 different versions that Hitchcock did of The Man Who Knew Too Much. There's also one from 1956. Okay, I'm going to scroll back down. And so we have some other choices. One of those choices is B. And this will allow us to show the genre, or list movies in a particular genre. So if I say drama, press the enter key, I see all the movies that are of type drama or genre drama, and there it tells me there are 8 movies in my collection that match that criteria. These are listed in this case chronologically because the data is currently sorted chronologically. If I wanted these to be listed alphabetically, I could change it back to an alphabetical listing and then choose B again, type in drama, and now they're listed alphabetically. Let's show our menu again. And C is search director. And I can put in a partial name such as Hitch. And what I see are all the movies whose director has a name with the partial characters of Hitch. Happens to be all 4. Alfred Hitchcock is the director here. And again, these now are listed alphabetically. If I wanted to view them chronologically, I could do a 2 and list them chronologically. Choice D on our menu is to look for somebody in the cast. I'm going to look for Tom Cruise. I'm going to type in Cruise, and it comes back with 5 movies starring Cruise. Happens to all be Tom Cruise. And again, these are listed alphabetically. That's my current sort method. We've seen the question mark shows the menu, and then finally there's an X to exit the program. And I'm told I chose to terminate the program. Goodbye. So until I type an X, I can do as many things as I want in my program. The X just simply terminates. And we use a while loop to make that all happen. Now that you've seen the program running, let's go back and look at our code of how we made this work. There are 2 files to this project. One is my custom class, which contains the movie class. I named it movie.py, and the name of the file here is in lowercase, but my class name, and I tend to keep these the same, my class name has an uppercase first letter. We usually capitalize our class names in Python, while our variables and our functions are all lowercase. So in the movie class, I created a function, and the name of that function is underscore underscore init underscore underscore. And that is a special function that is an initializer. In other languages, we refer to this as a constructor. This is what's going to build the instance of our movie class for each particular movie. And then there are some parameters here inside the parentheses, and the first parameter has to be self. But then it's all the information I want to pass to this particular instance. And this is in the same format as my data file, and then I have title, YR for year, director, genre, rating, and cast. And then I simply take those parameters and I assign them to attributes. Now the attributes are in the format of self dot and the name of the attribute. And I could have done self dot title equals title. That would work. The problem with that is the title attribute in that case can be accessed from outside of my class. That's called a public attribute. It's good programming practice to make your attributes private, meaning the raw data that's being stored in that instance can only be accessed through this class. And the way we make these private in Python, a little bit different from other languages. Usually in other languages we use the term private or public. Here, to make an attribute private, we precede it with 2 underscores. So my first line here is self dot underscore underscore title equals, and I'm going to pass the word title into that. Now I could have changed and made these parameters all different. I could have just used a T for my parameter for title, and it would be self dot underscore underscore title equals T. I just happen to use the same words here. You notice the year is a little bit different, so the attribute is underscore underscore year, and I'm passing it YR, so you can see a difference there. I could have made that year spelled out. I could have just used a Y. As long as I'm consistent and those match, we would have no problem. So this initializer creates the 6 attributes for each instance based on the data that's being passed it. And we're going to pass it this data from our main program as we read the data from that movies3.txt text file. And we'll do that in a loop. Then I have some other functions, and I'm going to get rid of this one here that says set sort type because that was actually a little experiment I was doing. I no longer need that. I can get rid of that. So we have some I have 6 methods here in which these are called mutator methods. Remember, I can't access this data directly. I can't change the data directly on the attributes. So I need a method to be able to do that if I want to change anything. Now, in a lot of cases, we don't want to change anything, and so you don't have to create these unless you're going to modify the data from an outside program or an outside file. But the way we do this is typically set underscore the name of the attribute, and then we need self again. Let's refer to the instance itself and the value we're passing to it. And then all we're doing is we're setting that attribute, that private attribute, self dot underscore underscore title equals value. And I use value here. I could have used title, but I use value because I created this first one, and then I copied it, and then I just simply pasted it 5 times, and all I had to do was change the name of the function to reflect the attribute and change the attribute. And I see I have a mistake here. This should be 2 underscores. Self dot underscore underscore year equals value. So I have 6 of those, all set to set underscore and the name of the attribute. And then I have what's called accessor methods. These allow us to get individual pieces of data from the instance. And all I'm getting here is each of the attributes. And it's basically the same thing as we saw with the set, but it's a get underscore title. In other languages, we sometimes refer to these as setters and getters. In Python, we refer to them as mutators and accessors. I kind of like the setters and getters better. It kind of relates a little more to how we code these things. But here I have get title, and my parameter is just simply the word self. And what I'm returning is that attribute of self dot underscore underscore title. And I copied and pasted that for 5 more times and simply changed the name and the attribute that was being returned. Then I have another special function, just like the init. This one is underscore underscore str for string, underscore underscore, and my parameter again is self. And all I'm doing here is returning a string, and the string is concatenated from all of the data of that instance, all of the attributes. And this is that format I showed you when we run our file. We want the title and the year on the first line, but I want the title to be all uppercase. So I use the dot upper. And then the next line I'm going to indent a little bit, show the genre and the rating in square brackets. And then the next line is going to say director, a space, and the name of the director. And the last line is going to be that comma separated list of the actors and actresses, which is my cast attribute, my underscore underscore cast. So if I print an instance in my code of the program, that print statement actually comes and gets this return value. So I can print an instance of my movie class, and it's going to show all this information. And the last one I have here is another special one called underscore underscore LT. The LT stands for less than underscore underscore. And again, I'm passing it self and other. And what this is going to do is going to sort my list based on the attribute that I'm looking at here. So I'm returning self dot underscore underscore title less than other dot underscore underscore title. If I'd wanted to do the year, sort by year, I could have done that with the same thing, but just changing the attribute from title to year. And I got that one commented out. I just want you to see the difference there. However, I can only use one attribute in this return value for the less than. And we'll see that in operation in a little bit. I saved this whole file again as movie.py, and then I came over and created my program file. So my program file I named as cs156 underscore 06a underscore movies underscore database underscore hustedde.py. And here I'm importing movie. I'm going to import this class file so I can access it. I then have my main function. And my main function, of course, is called by the main statement at the very end. So here's my main function. I'm going to create a global list called library. And I'm going to create that as an empty list to start. And then I've got a method here called read data. So in read data, I created a method. So we have our definition of read data. Again, I've got a global variable of data file and library, and I'm going to use a try except in case there's problems. And sometimes when you try to open an external file, you might have that file doesn't exist. You might have something wrong with the file, or there might be something wrong with the data as to how you're reading that in. It doesn't conform to the format you're expecting. So I want to do that inside a try. And if this try has an error, if it throws an exception, then it's going to run this except clause or except fork of something went wrong, data not read, and I can print the message that was generated, that EX, because I'm handling except with an exception as EX. I could have said exception as ERR, and then I would print ERR here. So that's how we handle the exception, but let's look at what's happening in the try. We're going to open our data file of movies3.txt. So it's going to be in our same folder as the program and as our movie.py file. So all three of those are in the same folder. I'm opening this for reading. So that's why I have the R in single quotes there. I'm going to read the first line, so datafile.readLine, and I'm going to take that line and I'm going to strip out the new line character at the end. Remember that when we read one line at a time from a data file, it's going to include that new line character or carriage return at the end of that file. So this first line I'm reading in is that header file that we saw in our data file of the title, vertical pipe, year, vertical pipe, director, so forth. I don't want to handle that. I'm just going to read it in, so it's kind of ignored. And then I'm going to read in the second line. That second line is going to be the first line of my data file, the first data record. I'm going to do the same thing here. I'm reading it into my variable line. I'm going to strip out the new line character, and then I've got a loop. And this loop is going to execute as long as the length of line is greater than 10 characters. I probably could have made this 3 or 5 because my concern was I might have some lines in that text file that are empty. All they have is a carriage return or a new line character. So I figured a data file is going to have at least 10 characters in it. So I just set this while the length of line is greater than 10. So I want to make sure that line has meaningful data. And then I'm going to split that line based on my delimiter, which in this case is the vertical pipe. So I use split, and in parentheses, quote, vertical pipe, quote, and I'm going to take that value, so I'm applying the split method to the value of line, and I'm going to assign that to items. Now items in this case is going to be a list. There should be 6 data items that are split based on those 5 vertical pipes that it encounters. I'm going to take library, which starts out as a blank list. Each time through the loop, though, I'm going to append to that list my movie.movie. This is the name of the file, lowercase, the name of my class, so it's .movie with an uppercase, and then what I want to pass to it. I'm going to pass it item sub 0. It's coming from my split list here. Item sub 0, item sub 1, item sub 2, item sub 3, item sub 4, and item sub 5. And I'm just going to carry this on the next line so you can see this code a little bit better. That's going to add the movie instance into my library list. And then I need to get the next line. So I'm going to repeat that line equals datafile.readLine. I'm going to strip out the new line character. It's going to come back to the loop and say, is it more than 10 characters? If it is, I'm going to split it. I'm going to append it to the library, and it continues that loop until all the data is read. When it finally reads a line where there's nothing in it, or it reaches the end of the file, this loop is going to end, and it's going to continue down here by closing that data file. Remember, we always want to open our file, either read or write to it, and then close it. And assuming that's all successful, I'm going to print a statement that says movie data has been imported. If it's not successful, something went wrong, we're going to print something went wrong, data not read, and our error message or exception message. That's going to read in the data. So it's going to do that automatically as soon as I start my file, as soon as I start my program. I've got a couple comments here. We can ignore these. These were just as I was doing some testing. In fact, I'm just going to take those 2 lines out so there's not any confusion. My next line, I have a variable called choice, and I'm setting it equal to a question mark. And then I've got a while loop. And my while loop is going to continue as long as choice does not equal x. If it equals x, my program ends. So if choice is a question mark, which it's going to be initially, I'm going to call a method called show menu. So here's the show menu. All I'm doing is printing the menu and the different options that are available there. It's just a series of print statements. Once it prints that menu, it's going to come back to here and it's going to run this next line where it's going to ask for the choice again. And now we're asking the user to enter their choice, whether it be an A or a B or a 1 or a 2. So here's our different options: 1, 2, A, B, C, D, question mark, or an X. So when they enter that choice, and let's say they then enter a 1, we are going to sort our library, and our library is that list of movie instances, and I'm going to call sort. Now when I call sort of the library, since they are movie instances, it's actually going to come over to our movie.py file, and it's going to grab or look up this function of our underscore underscore lt underscore underscore, and self and other allows it to go through the list and compare each of the items, and it basically ends up returning a sorted list. Once we've done that, I'm going to print the statement: data has been sorted alphabetically by title. Now if I enter a 2, I can't have another underscore underscore less than underscore underscore, so I did this another way. And here I used the sort method of the library as a list, and I passed it a key. And the key I passed is what we call a lambda expression. Now the lambda expression really goes beyond the scope of this course, but it's a way of doing an anonymous function, and I simply chose XYZ as the value I'm sending it, but I want to take XYZ and get the year of that each instance. So XYZ refers to each instance in my library, and I'm getting the year. It's going to come into our movie.py file and find this function of get year, and it's going to return self underscore underscore year. That ends up sorting the data, and again I have a print statement that says data has been sorted chronologically by year from oldest to newest. So those two methods sort our library list in slightly different ways. And then we have our elif of choice equals A, and we're going to call a function called list movies. And so here is my list movies method. It's very short. Again, I'm going to reference my library as a global value. And once again, I have a method in here that we no longer need. I'm going to get rid of that. It's just 3 lines now referencing my library. I'm going to use a loop for movie in library. I could have called this XYZ or Fred or Zebra, whatever I want to name it. As long as I use the same name in the print statement, it's going to print each instance in the library. Now when I call print movie, or again if I change this to, oftentimes I like to use XYZ as my variable, I can do it that way. And so print XYZ, since XYZ is a movie instance from my movie class, it's going to come over again to our movie class file and look for this underscore underscore str underscore underscore. And it's going to return the information about that particular instance, which is 4 lines of information. It's going to print that. And I'm going to get that whole sequence of the movies being printed in whatever order they're in the library. Once that's done, we're going to come back up here to our main function. It's going to give us a chance to enter another choice. Remember, on the if, elifs, or else, only one fork runs, everything else is ignored, and then it's going to continue with the statement after that structure. If I type a B, we're going to go to list genre. Here's our list genre. We're going to let the user enter the genre name they want, whether it's drama, comedy, thriller, action, adventure, whatever they're looking for. I'm going to print a little header here of the listing of that particular genre of movies. I'm going to set results equal to 0 because I want a counter of how many movies it returned. And then I just simply use a loop. I'm going to go through the instances of the library list. I'm going to create ABC as a variable, which is going to be the string of xyz.getGenre. And again, it's going to use that method from my movie class and return the genre name. And then I'm going to compare abc.upper to genre. In genre, we've already created as upper, so we're doing two fully uppercase values being compared, and if they're the same, I'm going to print XYZ, and I'm going to add 1 to results. Then at the end, I'm going to print the number of movies that were found in that genre if the results were 0. If the results were not 0, I'm going to print no movies found for genre whatever. Genre drama, genre comedy. And then I'm going to print that prompt. Okay, so I'm storing this in a variable called prompt, whether this is a ternary operator. If the results are greater than 0, if that's true, this is what happens. If it's false, this is what's assigned to prompt, and then I print the prompt. Once again, once that's done, it's going to continue with my while loop and give us another choice. Now, if my choice is C, we're going to run a method called search director. And the search director here, again, is going to give us an option to enter the director's name, and that can be one character, it can be a last name, it can be a first name, it can be both first and last name. Whatever we put there, that's going to have a direct match into the director field of any instances of our library list. I simply again print a header saying listing of movies directed by and the name of the director. Set my results to 0 again. We want to have a count. Going to go through that loop one more time, and I'm doing this the exact same way we did the genre, except rather than looking for the genre, I'm now looking for the director. And I'm looking to see if that director name from the instance contains, I'm going to use find to do that, if it contains the director variable value. So as long as that does not equal -1, meaning it found a match, I'm going to print the movie information and add 1 to results. Going to create my prompt again as far as how many movies are found and print that. The search cast, which is the next one in our menu, this is item D, works the exact same way. Basically, I just copied and pasted search director to search cast, changed the name of the method, changed enter director's name to enter name of actor/actress, put it into an actor variable rather than a director variable, created my header to show the name of the actor, and then again in a for loop, I'm getting cast this time, casting it to ABC, and then checking to see if abc.upper contains, using the find method of our actor variable. If it's not equal to -1, meaning it found something, I'm going to print the movie information and add 1 to results. Set my prompt after that loop is finished of either how many movies are found or no movies are found, and print that prompt. And that continues then back up to my main menu. And this loop just simply continues until the user enters an X. So while choice does not equal X, so once it equals X, this loop stops running. We go out of that loop and continue with the next line. I've just chosen X to exit the program, and I get the print statement, you chose to terminate the program, goodbye, and our program stops running. So that is the code for my solution of the movie database, reading in a data file using a custom class that we create to contain the instances of the movies with our 6 data items of title, year, director, genre, rating, and cast, having some mutator methods, most of which we really don't use, and some accessor methods, some of which we do use, and then our method to return a print string, and our method to do a sort based on less than. So it's sorting from A to Z. And then our main program, everything's operating in the main function with some other functions that it's calling to do specific tasks. The nice thing about doing it this way, if we had a team working on this, I could have one person creating the movie class, another person maybe creating the main method and then specifying all the other methods that are needed, and we could have one person creating each of these methods. We all come together and we can create this as a team very quickly because each of these are standalone. All we need to know is what it has to return or what it has to do and what the name should be. And then, of course, the movie class could be reused in another program if we need it. And each of these methods could be copied and pasted into other programs as needed and tweaked. So it gives us a very elegant solution in Python to work with data from an external source, reading that into a library of instances of a custom class and working with those instances. In summary, I'm just going to kind of slowly scroll through each of these methods. So if you want to create this and type in the code, so here is our class movie, and you can pause and recreate this in Python. But we have our initializer. I have all the setters or the mutator methods, followed by all of the getters, or in Python referring to these as accessor methods. We have our special print method of underscore underscore str underscore underscore, what we're returning. A lot of concatenation going on there. I could have written this as a string with dot format and the values I want to put in the placeholders of format. You can do it that way if you like. And then finally, I have this method called underscore underscore lt underscore underscore, in which it's going to return the self dot underscore title is less than other dot underscore underscore title. So that's the movie class file named movie.py, and here is my program where I'm importing movie, creating the main method, creating our read data method, and the show menu method. And again, you can pause and type this information in. Then we have a method to list our movies, very simple. Our method to show a particular genre. Our method for the search director, which is very similar to the method for our cast. And of course, our final statement of main, so that everything runs and it executes that main function, which is the hub of this whole thing. That's the project. Have fun with it.